Good morning, ladies and gentlemen. I'm your moderator, James. If you have any questions throughout the day, please feel free to come and ask me, and I'll point you in the right direction. We're going to start the first presentation this morning, and I will hand you over to Mr. Gergely Révay.
Thank you. I will just put this on. I try not to destroy the microphone. So, welcome to my talk about automating binary analysis with Ghidra's P-Code. My name is Gary. This is the quick, short bullet points of what I've did in my life, but it's not so interesting. The point is that I do now security research at Fortinet's FortiGuard Labs. I'm originally from Hungary. I live now in Germany. I'm on Twitter and a little bit on YouTube, so you can find me there. So the agenda. So I'm going to talk about Ghidra, specifically the intermediate representation in Ghidra called P-Code. A quick disclaimer, I'm not a Ghidra expert, so I use it time to time whenever I need it. I actually went down using Ghidra because of a specific project I'd worked on, and I was positively surprised. So I think it's a really great tool, and that's kind of what motivated me to create this presentation, because I think it's worth to talk about both Ghidra and Ghidra P-Code. And so quickly, we'll talk about Ghidra itself, then Ghidra scripting, and then we will spend most of the time talking about the P-Code, and I will show some code as well so that we don't just look at slides the whole time. All right, so about Ghidra. If you don't live under a rock, you probably know Ghidra. It's a reverse engineering framework tool from NSA. This is the tool that everybody was very suspicious about when it came out because it was from NSA. Then NSA open sourced it, and now we are kind of okay because we can look into the code. But all in all, it's a very powerful tool, and it's a great competitor to IDA Pro, Binary Ninja, and Révay 2. And of course, it's free and open source, so that's a good point, against, for instance, IDA Pro. And if you have never seen Ghidra, this is how it looks like. Obviously, you cannot read it, but I just wanted to give you a general feel if you have never opened the tool. In structure, it's very similar to IDA Pro. The main difference is that Ghidra has the decompiler built in by default. So the default view is what you can see here is the decompiled code on one side and then the assembly code on the other side. Great little thing that if you select something in the decompiled code, it's going to highlight it for you in the assembly code as well. And Ghidra Scripts. So Ghidra, as all the other tools, offers you some kind of possibility to extend the functionality of the tool itself. In IDA you have IDA Python. In Ghidra, you have Ghidra Scripts. The only difference is what I feel is that Ghidra scripts are a little bit more integrated in Ghidra itself, as for instance, IDA Python in IDA. And generally, the two most important use cases to create a Ghidra script is one to automate simple manual tasks. So for instance, if you are reversing a malware and there is some kind of custom string encoding, then you can just write a Ghidra script and call it from the UI whenever you encounter an encoded string, and that's going to decode it for you. So this is one part, and the other part is to create fully automated tools. In that case, you can use Ghidra as a kind of reversing engine or a reversing binary in the tool that you are writing. This was my case, so I didn't want to use the UI, so I run Ghidra in Headless Mode, which I'm going to talk about later. and just use Ghidra to generate the decompiled code or get the contour flow graph and things like that. We'll talk a little bit about Java versus Python. Ghidra supports both, so you have the option to choose which language you use for writing Ghidra scripts. And we're going to talk about the flat API versus the SDK. Just quickly, the flat API is a small set of functions that you can use directly in your script, and the SDK is basically everything that's available in Ghidra. So Ghidra already comes with a bunch of scripts. This is the script manager in Ghidra. So this is where you can search and run your script. I think if you use Ghidra regularly, then it's definitely worth to once go through this script just to have it in your mind what kind of scripts are available for you, because some things might be already implemented that you might need for your work. You can also create Ghidra scripts directly here in the script manager if you don't need a fancy UI or anything. Other than that, then you can use Ghidra's development environment, which I'm going to talk about a little bit. So one short word about Python versus Java. So Ghidra is written in Java, so that's the native language of the tool, and also the Ghidra scripts. But I think at some point, people at NSA realized that not everybody likes to suffer, so they created Python, or provided Python support in Ghidra scripts as well. However, that's using Jython, which is a kind of a weird thing. So if you are just writing simple scripts, that it's fine. There is also a tool called Ghidra Bridge, which actually helps you use Python 3 and basically bridges Ghidra with Python 3. That's what it does. And it works pretty well, so I recommend to use that if you don't like Jython and you prefer to use Python 3. Now, although I don't particularly like Java, and the last time I used it was during my studies at the university, I had to come to terms with the fact that Java is actually so Ghidra provides such a great development environment in Java that I can't skip that. So ultimately, I started with Python, but I ended up using Java, and pretty much have to Google like every single line of things to do in Java. But it's still worth it because the pain with Python is that there are a lot of classes and methods that you want to use from Ghidra, which are of course all in Java, and you can use them in Python. But to figure out how to exactly use them, it's a pain. So like you find something in the documentation, and you have to think about how to translate this function call and class type to however it should look like in Python. So ultimately, it can be done, and you can even debug typing things in Python, but it's a pain. And as I said, NSA created a really great development environment. So there is an Eclipse plugin or a Ghidra plugin for Eclipse, which works great. So you can write your code in Eclipse. You can start Ghidra directly from Eclipse, and basically use the debugger in Eclipse while your script is running in Ghidra. So that's super convenient. So it's very easy to use. And ultimately, I would say that if you're just writing short scripts and you like Python, then you can try using Python. But if you want to do something more complex, then probably you save yourself some time and go with Java, even if you don't know the language too well. Headless mode, as I mentioned, for instance, in my case, I didn't need the UI at all. I just wanted to run my script directly on binaries. This is what headless mode lets you do. What you can see there, this is, can I? Yeah. So this is pretty much how you call, how you start your Ghidra script in headless mode. It looks a little bit weird. That's basically the only drawback. But you can kind of circumvent that by writing a wrapper script. Ultimately, you are just calling Ghidra on a particular binary, the hello.exe, and then tell Ghidra to run your script on this binary. So it's pretty easy and works fine. And as I said, in this case, Ghidra is just your reversing engine. You can do whatever you want in your own Java code and just use Ghidra for whatever Ghidra can do for your stuff. Now, Ghidra comes with two different APIs. One is called the Flat API, or actually it's called Flat Program API. This is basically a set of methods that are directly available in your Ghidra script. And it's like around 150 methods. And the whole idea is to provide stability. So the rule of thumb is that no function should be removed from the Flat API ever. And function signatures shouldn't be changed over time at all. So if you use IDA Pro and you ever try to use an IDA Python script from the internet, you might know the pain that you download the script and then it was written in IDA like 2 versions ago, which was still in Python 2 and used a different API. So ultimately, I think running random IDA Python scripts from the internet is a pain in the ass. So that's how it is. And that's what Flat API tries to solve. So ideally, if I write a Ghidra script today, which only uses the Flat API, that should be able to run in 5 years as well. So I think that's great, and it's going to save you a lot of time fighting compatibility. The other API is the Program API, which is kind of the whole SDK, and basically this is everything that Ghidra is. So, and this is what I meant that Ghidra script is very powerful, because practically you can use every class that is used to build Ghidra. So everything that's being used to develop Ghidra is available for you in your Ghidra script as well. That's also, it's a great power, but it's also overwhelming at times. So I spent a lot of time, browsing at documentation, trying to figure out what classes do, et cetera, et cetera. But the documentation is pretty good, and the source code is also there. So if you find a class that you might think that it does something that you want to do, then you can start to look at Ghidra's own source code to figure out how that particular class is used. Just to kind of try to give an example of the complexity of using Ghidra is, like if you want to use a memory address, that's not like just a hex number, because that would be too easy, because Ghidra has its own address class. So first you need to instantiate an address class using your memory address, and then you can use that address instance in all the other functions and methods that would require a memory address. But all in all, it's a learning curve, but it's doable, and again, the documentation is pretty good. So with that, we arrived to our first example. This is very simple. I just wanted to list all the imported functions, because that's often the first thing when you start reversing something, because looking at the important functions of binary can give you a good idea that generally what that binary might do. So, for instance, if it uses the Windows APIs for networking, then probably the binary does some kind of networking. So this is why I thought we can list the important functions from a script, and this is all the script we need. As you can see, I hope you see it. So one thing to point out that our base class is the Ghidra script class. This is what makes our script a Ghidra script. And we also need a run function, or run method to be Java specific. And then basically we have a Ghidra script that will run. And in this particular case, we take the current program field, which comes directly from the Flat API, and it provides you all kinds of information about the particular binary that you are analyzing. And in this case, we are just use the getSymbolTable function, here to get the symbols, and from that we create an iterator with the getExternalSymbols. So the external symbols are the imported functions, and basically at the end we just iterate through all these symbols and print them. Okay, so let's see that in practice. Yeah. Oh, so we lost that from the screen. Let me just try to put it somewhere. Yeah, there it comes. Okay. Yeah, so this is the first script, but we already talked about that. So I will just go to Ghidra. I have a binary loaded here. It's a very simple thing, and this is the script manager, as I mentioned, and you can see my activity scripts here. So I will just choose the first one, and then I run, and then some magic happened here. And this is basically what we did. If you see that I just listed all the important functions and printed the DLLs that they were important from. So that's pretty much what this script does. But I hope it gave an idea of, how a Ghidra script looks like. Yes, so now we know what a Ghidra script is, so let's go into P-Code. So P-Code is the intermediate representation in Ghidra. It's a register transfer language, so basically what it does, it translates every assembly instructions to a set of P-Code instructions. What you see here, oh, there's a laser pointer, cool. So what you see here, you can enable showing the P-Code in the Ghidra UI. Just not left-click here, because that would be too easy. You need to right-click and enable. It's totally trivial. But anyway, so here you can see this is one assembly instruction, and this was then this is the equivalent of this set of P-Code operations. The whole point of P-Code is that makes every instruction pretty specific. So, for instance, if you're looking at the jump instructions, for instance, a jump if 0, then to figure out whether that jump is going to be taken or not, you have to figure out which instruction changes the 0 flag the last time. To do that in assembly, you need to know which instructions have the side effect of changing the 0 flag. So it's not impossible, but it's very architecture dependent. So it's going to be different in different architectures, and you actually have to literally know yourself, which instructions might do that. Often this is done by test and compare instructions, but it doesn't have to be. It could be any other instructions that might change this flag. Now in P-Code, this is going to be very clear. As you can see here, for instance, this is where the ZF flag is set. So when you want to figure out the same thing in P-Code instead of assembly, then you can just track back to the last P-Code operation that actually sets the ZF flag. So it becomes very clear. Generally, the idea of using an intermediate representation is not new. It actually comes from compilers. So they also first lift the source code to an intermediate representation, and then do the transformation from intermediate representation to assembly code in a separate method, because the point is that the first part, when you lift from source code to intermediate representation, that's still architecture independent, and only the part when you translate your IR, so the intermediate representation to assembly or machine code, that's the only part that's going to be architecture dependent. And it's similar with decompilers as well. So all decompilers use some kind of intermediate representation to take the assembly code back to some kind of pseudo C code. Yes. And just to make it more complicated, there are two kinds of P-code in Ghidra. The one is called raw P-code, and the other is called high P-code. Now, I haven't found any kind of clear definition from NSA to what these are, so I will just explain what I think they are. Basically, raw P-code is the first stage. What you can see in Ghidra when you enable P-code, or what you see when you just list the P-code for an instruction. This is a clear translation of one particular instruction to these set of P-code operations. In this case, we already have a great, standardized structure of the P-code, and as I said, we have it's pretty clear all the things that are done by that particular instruction. However, we don't have higher level context to our code, so we don't have like function arguments, we don't have variables and all these kind of things. But it's already great help when we work in raw P-code. But then high P-code is gonna take us a step further to the decompiled source code. It's basically the last step before getting the pseudocode. This is, as I said, it's the output of the decompiler. So whenever you want to get the high P-code of a particular function, then we have to call the high function method with that particular function, which is going to run the decompiler on that function, and then in the high function object that we receive, we will have the high P-code available. Now, and the great thing with high P-code is this already has the same kind of context that we have in source code. So we have things like function arguments. So if there is a call to another function, then we can ask that operation what your arguments are, and then it's going to give us the argument. So it's not like in assembly you have to know that the arguments are pushed on the stack or they are transferred to whichever registers. You can just ask that particular high P-code operation what's your arguments. And similarly with variables. The var node is like the generalized data element in P-code, and if you have a var node, which is kind of a variable, then you can ask things like where you were defined, and then you get back the address, the instruction address where this variable was last set or defined. So at this level, we have already pretty sophisticated tools to navigate around in a binary. So why to use P-code? Because it's cool? No, probably not. So mostly because the fact that it's used by decompilers and compilers kind of shows that it's a useful thing to do analysis. One great thing is that you get a generalized structure that it's easier to navigate pragmatically than source code or assembly code. And you can also get the architecture independence, as I said, which is, I think, really great in Ghidra, because what that means is that if you write a Ghidra script and you only use P-code and never touch assembly, that means that your script is going to work on all the architectures that are supported by Ghidra's decompiler. If you would use assembly, then you basically would have to write a different script for every architecture you want to run it on. So this is a huge thing, I think. Might not be easy to always just stick to P-code, but it's definitely worth it in my opinion. All right, so everybody gets a demo. And so the second example is we are going to look at the P-code, and we are going to look at COM functions. The Microsoft Component Object Model, which is COM, is just a difficult way to interface with other stuff. So if I had to do this as my day job to work with COM objects, I would probably shoot myself in the foot. But I guess it's everybody's taste. But the point is that COM objects are interesting because malware often uses COM objects as kind of an obfuscation method. Because basically COM objects allows you to interface with other programs on Windows. So for instance, you can control an Internet Explorer instance using a COM object. So what the malware would do, instead of using the normal networking API to talk to the command and control server, it would just use an Internet Explorer instance and then talk to its COM object to do its C2 communication. Now, the reason why this is good for the malware is because it's much more difficult to spot. So, as I said at the beginning, usually if you just look through the imported functions and there is no obfuscation, then you will immediately spot that it uses some kind of networking, and you can just navigate there in the code, and then you can super easily reverse engineer what the C2 communication is and how it works. When it's done by COM object or using COM objects, then it's a pain just because using COM objects is a pain. So it's not going to be that obvious by looking at the code. So in this script, what we are going to do is just go through the binary and try to find out whether it uses any kind of COM object. It's kind of like a simple recon script, so you can run it on every binary you're loading in Ghidra, and it tells you whether there are COM functions used, and if they are, then you know that you probably have to investigate that later on. So let's see. So this is a second script. Here you can see I manually hard-coded all the functions that could be used to interact with COM objects. And then we do a very similar thing that we did in the previous script. So we get the symbol table, we get the external symbols, and then we basically iterate through them. And then here starts the difference. Then first we see whether the symbol we are looking at right now, whether it's in the list of our COM-related functions. If so, then we find that we found a COM function. We put specific attention to a co-create instance. That's going to be more important in the next script. But basically, we can figure out what COM object is used by looking at the function called to co-create instance. And once we find the co-create instance, we will look at all the cross-references. So basically, all the places where co-create instance is called from the binary to see every instance when a COM object is instantiated. And then we are going to print the call site, so the place where this function call is made in P-Code, so that we can have an easy look in the logs to what happens at that place. So for instance here, this is how we look at the cross-references. So we load all the cross-references, and then we get the instruction at that point. And just to show you, this is, for instance, this is how we get the basic block model of the whole program, and then get the basic block. This is what we want to pin to hold the whole basic block of that particular address that's interesting for us. And then, yeah, this is where P-Code is created. So we are talking about raw P-Code now. In that case, we just have an instruction, and then we say get P-Code, and then we get a P-Code operations array, and that's what we are going to print. So script manager. Oh wait, let's empty this and run this again. Bam. So we have much more interesting fun here. So here you can see that we printed that we find the OLA initialize, which we always going to find if COM objects are used, and then we found the co-create instance, and in this case we are going to go deeper into investigating that. So checking call sites, and then we see that we found a cross-reference. I don't know if I can zoom in, sorry. We found a cross-reference from this address to co-create instance, and then we are printing that basic block, and this is where you see the P-code. Obviously, it's not so easy, so it's not human readable. That's not the point. It should be, machine readable. For human readable work, you just use the assembly, and this is where the actual call is done. So this was our second example. So now we know that our binary uses COM objects, and we know that it calls co-create instance. So in the third example, we're going to go a little bit more deeper to figure out what that COM object might be. The two values that can help us in that are the CLSID and the IID. For instance, in Windows, you can look, so these are both UUIDs, so just huge numbers. In Windows, you can look up the CLSID in the registry. So basically, you find a CLSID, you go to the registry, and you look it up, and then it will tell you what program that is. So it's going to tell you that this CLSID is going to call Internet Explorer, or it's going to call whatever. So this is how you can figure out what COM object is being instantiated in your target application. The IID is a bit more tricky. Probably you will need some time in Google to figure out what a particular IID refers to, but it's still useful to recover. All right. So the first thing you are going to spot here is that it's already a lengthier script, I would say. So it now already feels like it's not a script, but a real program. Partially because, as you can see here, we have to set up the decompiler at this point because we are going to use high PCode. Setting up the decompiler is pretty much boilerplate, so you can copy-paste it from any other Ghidra script that uses the decompiler. So it's not too difficult, but it has to be done. And for instance, this is how a function is decompiled, or the decompiler is created, and then we call get high function, and then we are going to have the high PCode. There are a couple of helper functions just to get GUID from byte array, just to help print the UUIDs in a human readable form, not just as a byte array. And if we scroll down to run, yeah, it's pretty much the same, except that once we find co-create instance, we go and call the find CLSID and IID function, and that's gonna do the it's gonna look up the function, then it's gonna decompile that function, and then we are gonna iterate through the high PCode elements, and this is basically why we are using high PCode at this point, because once we find the call instruction here, so we figure out that this operation is a call, then we can do things like get input, and we tell that we want the first input to that function call, which is, if you looked at the image on the slide, that's going to be the CLSID in the co-create instance function call, and the fourth input is going to be the IID. So this is why P-code is cool, because we don't have to do any kind of backtracking or anything to find the arguments of that function. We can just call the get input function, and it's going to tell us. And so let's go here and run the third script. Bam. And It's mostly the same, except here at the end. And here you can see that we printed the CLS ID and the IID. So great, we have some useless numbers here, but they're not so useless. As I said, you can look this up on Windows. For instance, if you run Ghidra on Windows, you could even implement it in your own script to look the CLS ID up from registry, or you can just start Googling and figure out what these IDs are. And at that point, you're going to know whether your binary talks to Internet Explorer or whether it tries to control the firewall, or whatever it does using the COM object. All right. And we are pretty much at the end. So a quick recap. So Ghidra is great, especially if you don't want to pay for commercial tools. Then I definitely recommend to check out Ghidra. P-Code and the SDK are very powerful for automation. So I definitely recommend trying that out and experimenting it a little bit. It's very well documented. I actually much prefer the documentation of Ghidra over IDAPRO's documentation. But ultimately, I'm not a fanboy. I prefer to choose the tool depending on the tasks. So if your tasks require you to use Ghidra and P-Code, then use that. If you want to use Binary Ninja, then or IDAPRO, then do that. A few references. Alexei and Rolf, they wrote a few cool stuff about using P-Code. And Carlos, a friend of mine, helped with a couple of ideas. And that's me. So if you have any questions, let's hear it. If not, then you can find me later during the 2 days. So come to me and we can talk, or you can reach out to me over any of these channels. So yeah, there's a question. Great. Yeah, I will push it to GitHub. So I have an account on GitHub. You can search for my name and then you will find it. Sure. All right, then, if no questions, then thanks very much and have a fun conference.
Thank you, Gergely, for the very professional, informative presentation. We'll just take a few minutes before we are ready to start the next one. Thank you.